Testing potential zeros. I'll give you a chance to read the definitions. Now here we have a definition about real number zeros are the x-intercepts of the graph of a function. So aside from being the x-intercepts, we can say the word root of an equation, and the other term is zero also. Now referring to the word zero, it's if you remember the remainder on the previous presentation. So if the remainder is 0, then that k is a root, the x-intercept of the graph. So those terms like 0, roots, x-intercepts are just the same. So in order for you to check your answer also, you may graph your f of x, and you can see the x-intercepts. Those are your real number zeros. So let's have an example. Let's say you're given with f of x equals x squared minus 5x plus 6. And your k here is 2. And then you're asked if k is a 0 or not. So what we can do here, we can use different ways in order for us to find whether our k, that is 2, is a 0 or not. So remember, if you use the remainder theorem, the answer should be 0. So the k equals 2 would be a 0, or the root of the f of x. If you're using the synthetic division or long division, then the remainder should be 0 in order for you to say that k is equal to 2. So let's start with using the remainder theorem. Now here, we just want to know what would be our remainder. So that would be f of k. Our k is 2, that's f of 2. And then we plug in the values to the f of x. So replacing x with 2, that's 2 power 2 minus 5 times 2 plus 6. And here we can have 4 minus 10 plus 6. 4 minus 10 is negative 6, plus 6 is a 0. So this is our remainder. And the word 0 means that the k is one of the factors for x squared minus 5x plus 6, which is our f of x, or k is the root of the equation or expression x squared minus 5x plus 6. If you remember, in quadratic equation, we're looking for the roots. So that's exactly the same thing. Or you can say this is our x-intercept. So you have 2 comma 0, and that would be the x-intercept. It's the point of intersection between the graph and the x-axis. So 2 there actually is a 0 since we use the remainder theorem here, and the answer is 0. If your answer is not a 0, it means k is not the root of this f of x, and that is not a 0. So here we will say, therefore, k, which is equal to 2, is a 0. Okay, so this is the first method that we can do. The second method is we can actually use using synthetic division to find the remainder. So our k is 2, put it in a small box, and we're getting the numbers beside the terms here. So 1, then -5, and then 6. And then we bring down the first number, 1. 1 times 2, 2 is our k. The product is 2. We add, the answer would be -3. And then do the same procedure, multiply again. The answer is -6. And then we add, it gives us a 0. So we have the same remainder. So at this point, we're not concerned about the quotient. So the quotient is over here. So we're not concerned about the quotient. We're just concerned on the remainder. So if the remainder is 0, then therefore you can say k equal to 2 is a 0. Okay. So another word again for 0, it's the x-intercept. And another word also, it's the root of the f of x. Okay. If you're going to graph this, this is a parabola. So the parabola is opening upward, and one of the x-intercept of the parabola, it's at point 2 comma 0. Okay, so that's how you test using remainder theorem and synthetic division. The other way to do this is by graphing. So we can show you the graph. F of x, that would be our y, and our equation was x squared minus 5x plus 6. And if you're going to look at our x-intercepts here, that would be at 2 comma 0, and the other one is at 3 comma 0. So remember, these are our two x-intercepts for the equation y is equal to x squared minus 5x plus 6. So we're trying to test if k is equal to 2 is a 0. So by graphing also, you can tell right away without any calculation. So that's one of the intercepts. So 2 comma 0, or k is equal to 2 is a 0 for the equation y is equal to x squared minus 5x plus 6. Okay, so if you're going to test the 3 here and use the remainder theorem, the remainder would be 0 also. If you try other values aside from 2 and 3 here, you can try 1, you can try 4, then the remainder would be not a 0. So that would be, there will be a value other than 0. Okay, if you want to have an example that doesn't contain an x-intercept, so you can just translate this and move the parabola up maybe 1 unit or 2 units up, and then the parabola is right here, and there's no zeros at this point because zeros are the x-intercepts, so we have only y-intercept here. So again, in this example, there are no zeros for y is equal to x squared plus 2. So the only thing that you can have zeros when the parabola is a little bit down, or the vertex it's below the x-axis. So it's like if I'm going to change this into minus 2, then I have here my 0 and another 0 is right here. So those are the x-intercepts. Okay, so in general, if you want to test the potential 0, you can just graph it right away and see if you have x-intercepts. If you have intersection between your graph and the x-axis, those are your real number zeros. But note that the imaginary zeros will not be on the graph. So you have to calculate to find the imaginary zeros. Again, you can only see the real zeros or the real number zeros. The imaginary zeros will not be on the graph.